designing learning outcomes, student learning outcomes. I'm just going to talk very quickly about this and maybe give you a chance to see if you can write one, okay? Following this template. This is just one suggestion. This is a suggestion for how to write student learning outcomes that's based upon 4 parts, 4 elements. And my suggestion to you is if you develop a learning outcome using these 4 parts, it will be easier for you to assess whether students attain that learning outcome. Some people have difficulty with a couple of these, and you don't have to include them, but I suggest that you do. So a learning outcome should have the audience described, what it is you want students to learn, or the behavior, the condition, are there some conditions under which this needs to be learned, and then what degree of satisfaction, attainment, will you accept as evidence that they have achieved that learning outcome? So those 4 elements, I'll go through them a little bit more. They're called the ABCDs of behavior. So the audience is easy. It's who? By the end of this unit, by the end of this workshop, students will, interns will, engineers will. All right, so here's an example. By the end of this unit, students using a calculator and distribution of numbers will be able to compute a standard deviation on 5 examples given on exams with 90% accuracy. The behavior. This must be measurable and observable. Stated as verbs. Now these verbs are very important. I think in some of the other workshops here this week, you've heard about Benjamin Bloom. You've heard about Benjamin Bloom? Any hands?
Yes.
Yes, Bloom's taxonomy?
The domains of learning.
Those words in Bloom's taxonomy match to different levels of learning. We'll talk a little bit more about that. But it's interesting. We often use words like, by the end of this unit, students will understand. Students will know. They're too general. How do you know understand? You need to find a better verb. Measurable verb. Can you think of anything to replace understand or know?
To describe, to list.
Describe, list. Define, explain. Describe. Again, you can describe it.
Compare.
Solve. Excellent. Here's some better verbs to use. Illustrate, compare, order, create, define, build, estimate. All of these are a little bit more measurable than words like understand or know. They describe a more discrete, specific behavior. So here's an example. By the end of this unit, students using a calculator and distribution of numbers will be able to compute a standard deviation on 5 examples given on exams with 90% accuracy. So compute. Condition, what the instructor will allow the students to use in order to complete the instruction. An example, by the end of this unit, using a calculator and a distribution of numbers, students will be able to compute a standard deviation on 5 examples given on exams with 90% accuracy. And then finally, the degree of accuracy that the learner has to meet in order that his or her performance can be judged proficient with 100% accuracy, or on 5 examples given with 90% accuracy. Okay, so what I'm trying to get you to think about is more specificity in your description of your learning outcome. So if you're interested and willing, let's see if you can take a chance and write one. Think about a course that you're teaching or will teach or have taught, and see if you can write a learning objective that has those 4 components. I'll give you a couple of minutes. I'd love to see pencils moving. It's hard to write when you're not writing. I don't want virtual writing. Then I would ask for 1 or 2 volunteers to share. And the people who volunteer and share get extra credit. Excellent, working hard, very good, thank you. What a cooperative, this is the most cooperative group of teachers that I have ever taught in Saudi Arabia on a Thursday in 2018. Okay, any volunteers? Yes, sir. And you get, actually the first volunteer gets double extra credit.
By the end of the course, the student should be able to determine the age of farm animals through examination of dental samples easily without mistakes.
Without, how many mistakes? No mistakes?
No
Zero?
mistakes.
So say with 100% accuracy.
100% accuracy.
Okay. Yes, ma'am. Excellent, very good, I'm sorry.
By the end of this course, the student will be able to write coherent paragraph with 100% accuracy.
Okay, that's a little different because coherent
Paragraph.
is too nebulous. What is coherent? What would be coherent for you
Yeah.
might not be coherent for
Accurate
me.
sentences.
Well, you need just to define coherent. Use a different word.
We move to full sentences, grammatically.
Okay, so then that's better. That's more specific. Yes, sir.
As for me, I'm teaching medical and veterinary entomology. By the end of the course, I am looking for students, or I hope the students able to understand what are arthropods, and which arthropod is benefit and which arthropod maybe hazard to us or to the environment, affecting the or as a vector of the disease or something like this, and to understand how to differentiate between insect and arachnids, and to understand yes, the rules of these things.
You have like 6 objectives all into one sentence.
Yes, okay.
All right. Let me thank you for your contribution.
Yes.
However, first of all, when you're writing learning objectives, you don't hope. You students will.
Yes.
You don't hope that they will. They will. And you use the word understand again, and I can't measure understand. I need something more specific. We'll be able to describe. We'll be able to compare one invasive thing from another. So you just need to define that a little bit more specifically. Yes, man here, yes. Nice and loud, please.
At the end of the course, students should be able to solve problems in first law of thermodynamics by 90%.
All right, be able to solve problems on thermodynamics. Great. Yes, sir.
Students develop ability to apply software engineering principles to build software modules.
So apply. Degree of accuracy, do you have that at the end of that?
We use the principles, so if they apply it, be able to apply the principles, that's...
How do you know that they've applied it? What criteria are you going to measure that against?
We give them, for example, case study, examples, and they have to work in a team to develop the product.
Okay. One more. Yes?
By the end of the course, the undergrads will be able to design a layout for a biosensor using AutoCAD with 100% accuracy.
Fantastic. That's the best one I've heard in 4 days. Because you used words that I didn't understand.
That's why.
Excellent. Very good. One more?
No, I just have a question.
Yes, sir.
There are courses that you can, these are not related to the mathematics of these kind of things. Like how you do the measurement part, like in terms of the degree. So let's say your course is about defining something like anatomy or biochemistry. So in that sentence, how you add those degree. So students will be able to describe or define these terms. Now, how you add to this degree and condition? It's a traditional method of teaching.
All right, let me pose the question back to you. You ask someone to define something, how do you know whether they've defined it or not? Don't you have some criteria in mind?
How you put that inside this one sentence, that's my question to you. Like someone defined, I cannot say, okay, 90% accuracy. If definition is not 90% or 90% like that, they'll be able to clearly define. You can put the term like clearly define, right?
You can use that, but I still think then you're introducing a lot of subjectivity. Your students don't know what they're expected to do.
So you give me, I will give you the problem, and you solve it for me, see if you can do that. So let's say I teach the structure of amino acid, or like protein.
People have just done that.
No, I mean,
I'm not going to do it. They've just done it for you.
My point is that there are subjects that we teach, not all will be fitting in the same condition.
Okay.
Not all can be done.
All right. If you think that's true, I'll let you believe that. That's fine. Yes, sir.
There is one point. I personally agree with his comment, because what you have listed as an example was statistical example or mathematical example, and the verbs that you use to identify the point are mostly related to math and physics, but his mostly calculate, evaluate, describe, plot, all of these are mostly engineered. And what I need to say that all science now are going toward engineering. So you can use calculate in medicine, you can use calculate in pharmacy, you can use estimate in any kind of science. This is what I say.
Okay.
Judge. Yeah.
All right, you don't have to agree with everything. I give you the permission to disagree. All right? I give you the permission to disagree. I also give you the permission to agree. I'm not trying to convince you. I'm trying to show you what I think is a way to do this. Yes, sir.
I have a question. Is 90% or 100% up to the faculty member to decide?
Sure. Well, unless your department has some criteria and standards that students have to demonstrate.
Can't you put it after the fact that you had the marks and then get an average?
You could do that. Sure. You could do that. Yes, ma'am.
The degree here in the lab project is to present my KPI. It's true.
Say again?
The degree here, I have 4 criteria for writing an objective, learning outcome. The degree represents my KPI. This is what I need my student to achieve.
Right.
Should I include this for every learning outcome, or should I make it as a general for my course? For example, the student should achieve this learning outcome by 90 or 80%.
Okay, that's a very good compromise. You don't have to have degree for every one of these learning outcomes, but you might want to say, all taken as a whole, they have to achieve 90% of these. That's kind of what we do in criteria and reference grading. We set a criteria, and if we meet that criteria, you get the grade.
I have a question regarding the degree also, because it's the first time it's been introduced to me. Honestly, we don't have a degree in our, from where I work, we don't have a degree. So I'm the student, if they get 60, they will pass the course. It's like, it's embedded or implied. If the student gets all these outcomes by, let's say, they reach 60%.
All right, so 60% is a built-in degree for all of your learning outcomes.
So can I consider it this way?
Sure you can. Hopefully you're not teaching medicine, because I don't want to go to doctors that only know 60% of the stuff.
Yeah, the student here, if they get 60, they will pass 60 out of 100. They will pass the course.
Everybody stand up a second. We talk about, I mentioned Benjamin Bloom, and a number of you are aware of Benjamin Bloom. Benjamin Bloom in 1957 or so was a psychologist who started to think and say, not all learning is the same. Not all outcomes are the same. Some learning is more difficult, higher level than other learning. And so he came up with what's called a taxonomy of cognitive learning. Taxonomy kind of means a qualitative ranking of different things. And subsequently, others have added to that. There's an affective taxonomy and a psychomotor taxonomy. Some of you, if you're teaching like dentistry or medicine where there's, physical manipulations, that psychomotor domain may be very important to you. Some of you who are teaching poetry or art or aesthetics, the affective domain may be more important to you. For most of us, we focus on the cognitive domain. All right? That's the attention of most academics, generally. Have a seat, please. Here's another way of looking at the Bloom's cognitive domain taxonomy. And again, this maps to the verbs that you use for learning outcomes. So let me see if I can interpret this diagram for you. You notice the arrow is going up. That signifies that those things at the top are more difficult, more complex. They're of higher order. The elements on the bottom are important. And as a matter of fact, unless you have a basic level of understanding or remembering, you're not going to be able to move up this cognitive arrow, this ladder. So advanced thinking, advanced learning is built upon more basic thinking, basic learning. Very simple. So And they're all important, but there was a famous book written by an author by the name of George Orwell, English writer, right after, actually it was kind of an indictment of communism.
1984.
And it was called 1984. And that's a different book. I'm thinking of Animal Farm. And in Animal Farm, there's a statement that all animals are equal, but some are more equal than others. All of these are important. They're all equal, but some may be more important than others. So the most basic form of learning is what is called remembering. Recalling, the ability to recall and recognize information. The next higher level is understanding. Once we kind of are able to remember and list and describe, name, then we can understand it better. We move up to understanding, interpreting, summarizing, paraphrasing, classifying. And if we understand it, we can apply it. And if we apply it, we can analyze it better. And if we analyze it, we can evaluate it. Much more complex thinking goes on. And then the most highest level of thinking and knowledge is the ability to create something. So think about the words that you use in your instructional objectives, those verbs that you use. I'd like you to, if you have a course and you've developed instructional objectives, go back and look at them. Or if a course has been given to you, go back and look at them. Where do they fit on this hierarchy? Are they all down in the lower level areas? Or do you have a mix? Or do they focus on the higher level, higher order thinking? It's important to look at, because if you're teaching an introductory, I used to teach Introduction to Psychology, and most of my learning outcomes were understand, remember, understand, apply. 1 or 2 times I would analyze, and maybe I would never get up to create, but I might have a question on, evaluate these 2 theories and come up. It's okay. But if I was teaching a senior counseling theories course, I would assume that they knew all those lower level things, and my goals would be more of the higher level thinking. Does that make sense?
Yeah.
To you? Now there's another term that's used called alignment. And when you're designing a course, alignment is important. And what does alignment, anyone tell me what alignment means? Yes, sir.
Alignment means there is some sort of alignment between the learning outcomes.
You can't use the word in its definition.
Okay, there is suitability between the learning outcomes and the teaching strategy.
Okay.
This is alignment.
Okay, so they're in agreement, they're in concert. So if I say, if my course goal, one of my course goals, kind of a meta goal for the course, is to facilitate problem-solving ability. Then my instructional goal, my instructional technique is to lecture, information giving, and I test using multiple choice questions. I would have a difficult time proving alignment in that class, because if problem solving is my goal, I don't know about you, but I don't think that students can solve problems unless they're given an opportunity to solve problems.
Yes.
It's not a skill that you learn through lecturing. It's a skill that you learn through doing. And I don't know about you, but I think it's very difficult for me to develop a multiple choice test that really assesses problem solving. Rather, a better way would be to give them a problem and solve it on the exam. So that's what we mean by alignment. So after you have decided what your course goals are, and you've designed some student learning outcomes, some student learning goals, then the question in your course design is, how will you assess whether students attain these or not? So that's the assessment component in this model. And I suggest to you, as you're designing a class, that you need to pay attention to two kinds of assessments. Two kinds of assessment. One is summative assessment, and the other is formative assessment. Can anyone tell me what summative assessment means?
Summative? It's the kind of assessment that is administered at the end.
Okay, and what does it try to measure?
Yes.
What does it try to, it's usually something kind of at the end. What does it try to measure?
I'm trying to measure the level of learning.
Okay, the outcomes, the attainment of the goal. So the outcome, the end product. What about formative assessment? Someone? Yes?
It's the way that the method that I'm using, is it right method? Like, is it working or not?
Okay, is it working? It's a process assessment. Any of you, have any of you had the opportunity to write and submit a grant to the National Science Foundation in the United States? NSF? Well, I've had the luxury of writing a number, and actually a few of them have been funded. I've written a lot of number of them and a few of them. But NSF, National Science Foundation, requires that you have summative assessment and formative assessment in your grant. 10% of your budget needs to be put into assessment. And some of that needs to be process assessment. And really, if you have a 5-year grant, they determine that every year you have to submit a status report, a process report. How's it going? Are you attaining your desired outcomes? Well, when you're designing a class, I think you need to do the same thing. You need to not only design summative assessments, those grades, the tests, the exams, but formative assessment into the class.